started. We are talking about vectors on the plane, and you guys, almost everyone did Khan Academy, so you have some experience already. And for the first 7 minutes, you will have an understanding of what I'm talking about, and hopefully we will be able to quickly move on. Okay, what is vector? First of all, we have some scalar values in physics or in real life. For example, number of slices of pizza could be described as a scalar number, or how much the person will weigh after that will be described as a scalar number. But once you need a direction and magnitude, it will be described as a vector. So can anyone give me an example of vector? What in physics could be described as a vector? Speed, velocity. Very good. So this value should have direction and the magnitude, and that's what vector is. Let's quickly draw a picture of the vector. Any vector. A vector has the beginning and the end. The beginning is called, who remembers how the beginning is called? Initial point. And the end of the vector is called terminal. Let me assign some values. Let's say it's P and Q. And the coordinates of P was, will it be x1, y1? I'll let the coordinates of Q be x2 and y2. Then the vector PQ, if you would like to write the vector PQ in the component form, can anyone please tell me the components then of the vector PQ? Well, we have right, x2 minus x1, change by x, comma. I don't have enough space, so I'll just go to the next line. y2 minus y1, this is a component form. Basically change, horizontal change, comma, vertical change. That's the components. You did this in your Khan Academy yesterday. How can I find the magnitude? So some students told me at the beginning of the lesson that they struggled finding the magnitude. Magnitude is actually the length of this vector. Let me scroll this down. The magnitude, PQ, and when you have this double line, that's called magnitude. And magnitude means, let me write it down in your notes, magnitude. In the other words, it's a length of the vector. And please tell me how to find the lengths of the vector. Go ahead. Pythagorean theorem, yes, if you have the vector on the coordinate plane, or distance formula. Actually, distance formula is the same as Pythagorean theorem. So, with that said, I can say that PQ magnitude will be, that's a distance formula, x2 minus x1 squared plus y2 minus y1 squared, take a square root. And if some people prefer to write it as change of x, that's Pythagorean theorem. That delta sign means change. Change of x plus change of y and also square root. These two are equivalent statements. This statement and this statement are equivalent statements. Instead of x2 and x1, I just wrote the delta. Some people prefer that, and some textbooks have that. So far, so good, guys? All right. You have enough time to write this down? Beautiful. Moving on, next thing is equivalent vectors. Equivalent vectors. And what equivalent vectors should have the same? Yes, thank you very much. Which means they have same magnitude and direction. You have to know two values in order to conclude that two vectors are equivalent. And let's discuss one question. My question to you is, given, oh, that's really not perfect, but given two vectors, let me call this R and S. R has coordinates 1, 2, S has coordinates 4, 4, and this will be P and Q. P has coordinates 0, 0, starts at the origin. Q has coordinates 3 and 2. My question to you, are they equivalent? Should be. They should be. Yes, they will be. But let's prove it. 2 steps. Find the magnitude first and find the direction. Magnitude is pretty simple. We will just use the distance formula. So RS magnitude. Can anyone tell me the number? Root 13. Very good. 4 minus 1, that's 3 squared, plus 4 minus 2 is 2 squared, and that will be root 13. I'm skipping this step because I think you know how to use distance formula, Pythagorean theorem at this time. PQ should be, please tell me who got the number for PQ. Root 13. We got the magnitudes. How to find the direction? What's the direction of the line? Right, but they both point into the right upper corner. But I need to be a bit more specific.
So you would like find how much for PQ, you find how much you shifted the x, and then go up how much you shifted the y.
Yeah, and what did you describe? Slope. Yeah, you described slope. Very good. Slope will show us the direction. Let's quickly find the slope of RS. I will just ask you for the number because you know it's y2 minus y1. y2 minus y1 over x2 minus x1. Please just tell me the number. 2 over 3. And slope of PQ. Perfect. Now I can prove, now I proved it. These two vectors are indeed equivalent because they have same slope and same direction. So good? So far so good, guys? Okay. And that should be very, very familiar to you. Next thing. Vector operations. Next is vector operations. Scalar multiplication. You did this yesterday in Khan Academy. It was one of the best assignments. I think it was pretty easy. For example, let's say you had vector u, which had components u1 and u2. u1 and u2 represent some numbers, like 2 and 3. I would like to find vector k times u. What will be the components of this vector? Go ahead. Perfect. All you do, you just multiply every component by this k, and that's what happens. Now let's try to represent on the graph. What happens on the graph when you multiply by some number k? Let's say you had original vector u. That was, let me write this down. That was your vector u. I would like to now construct 2u. How it will look like. Can you describe me? If you know u, how the 2u will look like. Sarah. Right? It will be doubled in length. Very good. Let me try to play with technology a bit. I will copy and let me paste. Can I paste it? Yep. And I will, there you go. So this vector will be 2u, and it's going the same direction, but now it's just twice longer. That's my 2u. Where negative u will be going? Opposite direction. So if I want to multiply by -1, it will just change the direction. It will be going right into opposite direction. So scalar multiplication is pretty simple. Take it, multiply by the number. Addition and subtraction. Number 2, addition. If we write in algebraically, that's pretty simple. So if addition, let's say two vectors are given. U has coordinates u1 and u2, and v has coordinates v1 and v2. And I would like to add them. So algebraically, that should be super simple. U plus v, and please raise your hand if you know the answer for this. Who knows the answer? Go ahead, Mud. Wait, that plus, we add in the x components, right? Plus v1, comma, u2 plus v2, perfect. we just add in the corresponding components, done. That's pretty simple, pretty beautiful. And let's discuss what happens if we try to visualize it. What happens on the graph? You guys have enough time to write this down? No? Someone needs time? All right, 10 seconds and I will move on. We have graphs to cover and then unit vector. I have about 7 minutes left. Hopefully you're still live. Okay, now graphically, how to add vectors graphically. How to add vectors graphically. Imagine given, this is our axis, x and y axis, two vectors will be given. Vector, I'm trying to make it up. This vector and maybe this vector. Yeah, this vector and this vector. Let's call the first one u and the second one will be v. And I would like to add them graphically. In order to do so, you can do it on the same graph or you can draw a different graph. Let's say this will be my different graph. What I will do, I will copy both of the vectors. It's easier for me to copy. I will just use some technology here. You can just copy your drawing. So take the vector, copy this vector. Doesn't matter where you put it. I prefer to put it in the origin, paste, but it honestly doesn't matter. You can put it whenever you want. I prefer origin. It's just easier from the origin. Take the second vector. Do the same thing with that second vector. Why I can do it? Copy the second vector, paste it. Nope. Technical issues, sorry. I swear I practiced before this lesson. Okay. I practiced technology, integration. Copy. Copy. Paste. All right, I give up. I'll just do it by hand then. But I tried. At least I tried. So what I'm doing, I'm taking this vector, and the initial point of this vector will coincide with the terminal point of my vector u. So now I'm taking this vector, I'm copying it. I'm doing the best I can. Probably I screwed up somewhere. U, this is my vector v. So the sum of the two vectors is, can I change the color, is from the origin to the terminal point of the second vector. So what I did is first of all, I copied u. You can leave it on the same place, but what you have to do, you really have to put v at the terminal point of your original vector. That's what you have to do. And then connect the initial point of your first vector to the terminal point of your second vector. People make sense? All right, that's how you graphically add them. Now, how to graphically subtract? That's a bit challenging. How to subtract vectors, subtraction. Let's discuss how to subtract vectors. Given the same information is given, I have two vectors. Let's have one vector u and one vector v. This is u, this is v. And I'm trying to do u minus v. So we know that subtraction is the same as adding the inverse, right? So let me rewrite it as u plus negative v. Do you agree with me? Right. Well, how can I show negative v on this picture? Flip my x and y. Why don't I just go opposite direction? Right? Let me actually move v a bit. So I will move it. I will move somewhere like that. So I just go to opposite direction. That's my v. That's my minus v. All right. So since it's addition, I'm doing the same thing, which I already did. I'm copying. That's my vector subtraction. What I will do, I will copy vector u, copy, paste, and I will copy on my new plane. I copied over here. then which vector should I take? V or minus V? The inverse. So take the inverse and put the initial point where? To the terminal point of my vector u. So I put my initial over here. Oops. I'm trying to draw. That's how it will look like. That's minus v. So finally connect this initial point, this point, connect with the last terminal point. Let me draw an arrow there. That's my answer. That's my u minus v. And guys, last thing, we'll take about 2 minutes. That makes sense, people? Last thing is unit vector. Last but not least, that's unit vector. Unit vector has same direction as the original one. So let's say, let's unit vector u, I will say u is a unit vector. I have vector v, and now from vector v, I would like to make a unit vector. The unit vector will have same direction as v, but the magnitude of unit vector will be how much? If it's a unit vector, how much the magnitude should be? 1. Very good. So this u will have same direction, but the magnitude of u will be just 1. Now, how to do it? Example, given that v is minus 2, 5, I need to find u, the unit vector. I would like to then divide every component by what? What do you think? I'm trying to make the lengths to be 1, so I'm dividing by magnitude of the vector. I'm dividing by magnitude of the vector v. So my formula then for u will be components of v minus 2, 5, each one divided by the magnitude of this vector. Okay, magnitude is minus 2 squared plus 5 squared. Take a square root. How much is it? Root 29. My vector u will have coordinates minus 2 over root 29 and 5 over root 29. I'll scroll it up in 10 seconds and write it down on the board, and that will be it. Okay, so finally vector u will be minus 2 over root 29 and 5 over root 29. And as I stated, this is unit vector. And if you don't believe me, I will encourage you to find the magnitude of this one. This is check. How can you check that this is indeed the unit vector? Okay, what's the magnitude of this? 4 over 29 plus 25 over 29. Take a square root. How much is it? 1. That's the proof that it's indeed a unit vector. Yes, sir? I mean, you can rationalize if you want to. But if the question is not explicitly stating rationalize, don't do it. And we are done with the notes. I'm stopping the recording.